Okay. Now, x is seventh over x is third. As I said, we don't want to just blindly apply a rule that we don't understand. We want to make sure we understand the rule so we don't forget it and get it mixed up. And so what you do doesn't make sense in terms of what it really means, then make sure, go back and double check you got the rule right. Okay. Now what this means is, this. I don't acknowledge cancellation. People do it wrong. And people can't seem to learn the rules for cancellation in any way that allows them to retain them. So I'm not drawing lines through things. And I don't want you to either. I want you to do this as so. Okay? Why did I do it like this? Well, what do I get if I divide x times x times x by x times x times x? Yeah. Some of you are holding up a finger, not holding up the wrong one, so I think you understand. Okay? Now, so, this equals then so that's just 1 times, and of course x times x times x times x over 1 is just x times x times x times x. So we easily take it from this form to this. And then it's easy to put it here. Then if we can count reliably, and if there are enough x's, it might be hard to count them. Okay. But we say that's x to the 4th. Okay? All right. Well, nothing hard about that, and that tells you what's going on. That's how you understand the law, the rule. Okay? Here, very similar, x times x over x times x times x times x times x. Right? And that equals what? Equals this. Okay? Because if you multiply this out, you multiply the numerators and multiply the denominators, you get this, right? So this has to be equal to this. So what we did is we just factored out the x times x from both the numerator and the denominator. And that equals of course 1 times is just this, and that's 1 over x cubed, or x to the -3. Okay? We good with that? Okay. So, now what's x to the a divided by x to the b? Okay. How can you use these numbers, the 2 powers of x, to get this? Well, what you're doing is you're taking 3 of these away from the numerator, right? Okay? If you take 3 of these away from the numerator, that leaves you 4 of them. So we want to say that this equals, well, I'm just going to cut to the chase. In this case, it'd be x to the a minus b, right? Now that turns out to be a rule. Does this rule apply here? right? Okay. See if it works for x squared over x to the fifth. Well, a would be 2 and b would be 5, so you'd subtract the 5 from the 2, get negative 3, right? This is the same as this, right? So this rule works. No matter what a and b are, the rule works. Also, of course, a positive power in the denominator is the same as a negative power in the numerator, right? Because that's the way negative powers are defined. X to a negative power is 1 over x to the absolute value of that power. Okay? And those are pretty easy rules. But you've got to be really straight on them. And if you understand these two examples, you understand the rules. And you don't just quote the rule, which you'll then forget in a day or two. You understand the rules, so you can always figure out what the rule is. Okay, well, let's apply these ideas to the first quiz problem. Now, everybody had different numbers for their exponents. But in all cases, I've got a negative 6 and a negative 9, okay? And 9 is bigger than 6, and in every case, if you have your numbers in order, this number will have been bigger than this number, so what I'm doing will follow. Okay. And if you didn't have them in order, you're still going to apply the rules in a similar way. Remember, you want your A, B, and C numbers to be in order. A less than B less than C. No matter how that works out with your name, you always switch it around so A, B, and C are in order. So then D, E, F, and G will be in order. Okay? Okay, well, this equals what? I can write this out. Well, first 4 squared is 16. Then we have x times x times x times x times x. Right? But then we have a y to the negative 6th and a y to the negative 9th, and that gets a little more complicated to write out. Because you get a complex fraction, you're going to get 1 over y times y, so forth. And then in the denominator, you're going to get 1 over 9 y's. I don't want to write all that out, okay? Now, what's 5 to the 0? Everybody that did the homework missed that, I think. Okay? People want to say it was 5 or 50 or something else, okay? I didn't see, I went through all the homework, I didn't see anybody that actually did that right, but maybe I missed it. Because I know at least a couple of people are doing it right today, okay? But anyhow, that's 1 times x times x times x times x times x times x times y to the negative 6th over y to the negative 9th. I don't want to do this, write them out with negative powers. It just gets too complicated. Again, you get a 1 over 6y's divided by a 1 over 9y's, and then you got to invert and multiply and all that stuff, okay? So I don't want to do that, but I could. And so could you. Be careful. What we can say is that this is 16 over 1, x to the 5th over x to the 6th. This is the way I work it out. Change my mind in the middle. Right. And now I can apply my rule. 16 over 1 is 16 times x to the 5 minus 6. Numerator minus denominator, right? And for reasons that you should totally understand, you should be able to visualize 5 x's in a row divided by 6 x's in a row. And see that you can factor it out that we got 5 over 5 x's over 5 x's times that one remaining x. But it's in the denominator, okay? So make sure you can visualize that. When you do this, visualize what you do to the extent that you can. When it comes to negative exponents, it might be a little harder to visualize, but the rule still works. It's y to the negative 6 minus negative 9. Subtract the power of the denominator from the power of the numerator. And now this equals 16x to the 1, y to the negative 6 plus 9. Don't skip that step. Don't do it in your head. On a test, you'll have enough time. You can take the extra 12 seconds it takes to write this step out. Okay? If it takes more than that, that's okay. You have time. That's 6x, y to the third. Okay? And if you have a case like this where the number down here is the 9 is bigger than the 6, then when you subtract negative 9 from negative 6, you're going to get a positive power. So if your numbers were in order, your A through G all in order, you'll end up with a positive power here. So if you didn't, then you want to go back and make sure you're applying the rules and also visualizing the rules as best you can. The better you visualize them, the less likely you are to get it wrong. Okay.